Okay, so we're also recording, and that means that I can officially start the webinar this week. Hello, everybody. My name is Vilana. I'm the community manager of WeAreDevelopers, and I'm super honored to be the host of this webinar session this week as well. Before we start with Peter and his session, just a couple of house rules. So feel free to actually write comments on the right side of our webinar tool all the time. Introduce yourself, tell us who you are, tell us where you're from, what is your favorite stack. Just introduce yourself there. Feel free to ask questions, very easy. We have also enabled the question mode already. So where you see the chat, you also see a place to ask a question. So in that separate Q&A mode, we will gather the questions, and at the end of the session, Peter will be answering whatever you have there. Share the event if you feel that somebody from your friends and colleagues are right now bored at home and want to learn something new. Feel free to share the event with them right now. There is no registration needed, so everybody can just jump in. And last but not least, this webinar complies with our code of conduct. So be kind, be inclusive, stay open. In case something happens in the comment chat, my colleagues are also here in the webinar, and they will be also scouting for inappropriate comments. You can always reach out to me or to Vessel or Gary. Their names are also in the chat section, so you can privately let them know that there was some disruption. Yes, I assume all of you know what WeAreDeveloper is, what we are, what we do, but just maybe for a couple of newbies, I just want to say that, yeah, besides the events that we usually do for developers in Berlin and in Vienna, we also have a job platform. So in case you want to get a new job or you are growing your team and need new people to join, feel free to visit the WeAreDevelopers.com website and see what opportunities they are, or post an opportunity that somebody else could be interested in for your team. And yeah, on the end, one more thing before we start. At the end, we're going to have a small giveaway for our next event in Vienna. So we'll be asking you a short question here, and then you answer the comments. First come, first serve. We'll give 2 times 2 tickets for the winter event in Vienna. Well, hopefully by that time, we'll be actually physically enjoying some sessions and not virtually. And yes, without losing more time, I'll give the word to Peter. Peter is the founder of PSPDF Kit. I'm always a bit confused not confused, afraid to misspell the abbreviation, but I think I managed. He's the founder, and he's also one of the meetup organizers of Cocoa Heads of Vienna, or Austria even. And as far as I learned, you also love memes. So if you have favorite memes, maybe you can also share them later with us. I'm going to mute myself, turn off my camera right now. Yeah, good luck, Peter. Enjoy, everybody, and we'll be connected later.
Awesome. Okay, I'm taking over here. First of all, hi, everybody. This is still this is still a little bit awkward doing conferences, but sitting at home. So I think we're all getting used to that over the year. I will look at the chat from time to time. So whenever I'm stuck, you can like type in and help me there, or you can like give me emojis. I also see that a few people follow me on Twitter and see all my adventures. So that's the Ralph inside joke. Amazon's calling me Ralph for about 10 years now. So so maybe I should also rename the company name. So I work at PSPDF Kit, and let's actually get this going. I'm going to share my screen. Now you see myself double. Yes, you should now see our glorious website. So this is not going to be a marketing talk. Just very quickly explaining what we do. We built a PDF SDK. You probably have a few copies on your phone. For example, if you use Dropbox on iOS or on Android, and you open a document, this is our software. So a lot of companies use this under the hood, DocuSign, SAP, Siemens, but also a lot of smaller ones. And I'm doing this for about 10 years now. There's a lot of code, and I had a lot of adventures on that. And the latest one is pointer events. So this is actually quite a surprise. Apple added pointer events in the last release of iOS 13.4. So like all the betas, there was no mention of them. And then basically people had to scramble to implement this within 1 week. We already shipped an update that supports pointer events. It's by far not done yet, but it's a good start. And today I'm gonna walk you through how we did this today. So first of all, I'm gonna make Xcode a little bit larger. You should be able to like go on full screen. To make this a little bit more convenient. And the very first thing is, my setup here is a little bit sophisticated. I use Reflector. It's a third-party app to mirror the iPad that's next to me on my screen. Because it turns out if you try to debug cursor events and you use your mouse to hover over things and then you go into debug, things get complicated really quickly. So it's a much better experience if you do this kind of development on an actual phone. And you see that it's connected via AirPlay screen mirroring. And what we want to do today is, you see, this is pretty much a default screen of our sample app. And this is an annotation. So I can select an annotation and move it around. And you see this round thingy. This is the cursor that Apple added when you connect a mouse or a trackpad with the iPad. So a little bit history on that as well. You could do that since iOS 13.0. It used to be just an accessibility thing. Apps couldn't really react to it. And then in 13.4, we actually got API for it. And that's basically where the adventure starts. So you see that my cursor moves to this really nice resize handles. They're all correct for every point of the screen. And that's all. This is what we want to replicate today. And it will take a while. It's actually fairly tricky to get this right. But first things first, I want to tell you a few more minutes about pointer events, because you actually get a lot of that almost for free. So for that, I'm actually using a third-party app. I'm being lazy and just use Kim Rössner's sample app, because he did a much nicer job to explaining the real basics. So you see, these are all buttons. And by default, if I use my cursor, a button wouldn't do anything. But if you use this nice one-liner, is point interaction enabled? You can also click in there. It is it's new API in iOS 13.4. Then you can set various styles. There is a highlighted style. So basically the cursor transforms into the button. There's a small lift, and everybody who has an Apple TV or ever did Apple TV development has seen this wiggly, Apple calls it lift. Then there is a larger version, and then there's various hover versions that change the shadow, potentially also transform. You also see that, like, by default, Apple already did a lot of customization. So like sections get dynamically, if you go in a text field, you see that the cursor morphs into text. Same for regular text. Section controls are edited. The slider doesn't actually do anything. Doesn't do anything. This one, all by default, doesn't do anything. And of course, the API will be physical, so you can also create complete dynamic shapes you already saw in my example. There's also a little bit of magic in there. So this effect where the whole control wiggles is a little bit dependent on size. So you see it works for small images. It doesn't work for large images. At some point, Apple decided that it doesn't look good if the wiggle is too large. But that's the basics. You can read up the basics on Apple's website. That's boring. We close that. We go again to our example. And what I did is I really just downloaded our SDK sample and did a really simple setup where we define a few classes that are overwritten. And this is our space where we want to work in. So the real magic is this code removes the existing interaction, because I've told you we already shipped a version that does pointer events. So once again, this is with the existing code. Now I already changed the code. I restart, and then you see that we removed the internal handler, because now we're going to rewrite the internal handler live. You see now nothing happens anymore. This is the start. You can also give me thumbs up or anything on the chat, so I know that people are still there. It's always a little bit awkward to talk in front of my screen and not hear anybody more, or be bored or be excited. Awesome, thank you very much. So where's our space here? So the basic structure is we are building a custom hover handler. This is one class that deals with the cursor. Now, this is simply an override. This is getting the setup done. The page view is the large view that you see here, and we want to do a custom cursor on the page view. So the first thing we have to do for that is we want a pointer interaction. Now, the API is pretty straightforward. If you did drag and drop, you've already seen it. Instead of doing the drag and drop interaction, we now have a new UI pointer interaction, which has a delegate. Now, of course, it immediately starts to complain that this is only available 13.4 and later. And we use one of the fixits because they are sometimes actually working. And we just mark the complete class as only available for iOS 13.4. I already in the setup made sure that it only gets added. And iOS 13.4 and older versions that we don't care. So this one is enough. And then, of course, you also need to implement the UI pointer interaction delegate. So let's see if a fixit probably doesn't do the right thing here, because we want to have a nice extension. A pointer interaction delegate. So if you look at the pointer interaction delegate, it's actually fun because it only has optional protocols. Everything is optional here. So what do we want to do? This one seems to define a region for the pointer. We don't need it yet. We just want to have a pointer style. So we take this one. And let's say, of course, it's also complaining about 13.4. And let's say we want just a very simple shape. So let's say shape, and we want the UI pointer shape. The pointer shape should be a rounded rect. And we create the CG rect 0, and height is, oops, let's do 50 and 50, and the radius, because we can give it a radius. And actually it doesn't want a shape, it wants a style. So we say return a pointer style. Also to the end when the completion works. And here we give it the shape. So if we run this again, and I'll give you the reflector, then it's asking if the session is recorded. Most likely, except if I screw up here, then we'll probably not record it. But I think it will be fine. So if you see now, I move around. As soon as I move in the page view, I have this interesting cursor. It's not really what we want. It's far from what we want, but it's definitely a start. See, here's the cursor normal again, and here it becomes this rounded blob. Now, rounded blob isn't really cutting it for us, but it's definitely a start. What do we do next? So, of course, there's other delegates. Again, we look at the delegate, and we already found one that also was looking interesting. If you're wondering, those two are for will enter and will exit region, we don't really need it in this example, but this one seems to be nice. It can define a region for the pointer, and so far we didn't implement it, which means everything is the region, but of course that's not really what we want. So we now want to have this is a little bit of an internal, but the page view has a resizable view. Resizable selection view. And the resizable view has a frame. And we check if the location of the request is within the frame. Actually, I got the name wrong here. It's annotation selection view. And if this is the case, then we return the default region. Otherwise, we return nil. So if we start this again, and I'll show you my live iPad, that's why it always takes a minute. You see that the cursor actually does nothing because right now there is no selection view. However, if I now tap on my annotation, then it moves into the cursor. So what we now already have is the cursor depends on just a specific region in our view. This is a good start. Remember, we want the knobs and not everything, but we're going to do this step by step. So I'm going to look at my notes. So next thing is we want to define which cursor modes we actually have. I'm going to be a little bit lazy and not type everything, just stealing from my copy here. But basically, we define an animation that has a few different cursor modes. The default we call arrow. You could also call it around blob, but arrow is kind of like more in line what you expect on the Mac, so we'll just go with that word. And then we have a few resize knobs. So if you draw it up, there's only so many resize figures that you want to. You have north-south, east-west, northwest, southeast, northeast, southwest. With that, we will be fine. And that in preparation of what we want to build, we probably need to store a little bit more data. If you think it through, the knobs have a specific size. There is, we basically want to store the size. So for now, we could do that with associated values in enums, but we know that this will get a little bit more complex. So having a separate struct that basically says the cursor mode and the arrow is the nicer approach. Now, what we need next is a little bit of space here, and we need a mapping that maps between the knobs. We have 1, 2, 3, 4, 5, 6, 7, 8, and the resize cursors. So a few knobs share the resize cursors. We want to not have the code to be too specific for those knobs. We want to always think in cursors. So we just need a simple map that translates one between the other. And I already wrote that as preparation. So you see that it basically defines resizable view outer knob, which is a regular enumeration, into the cursor mode that we just defined. This is very helpful because now I can iterate over all the knobs and already know which cursor I'm going to need. So as next, we need a function that we call hello cursor. And it will operate inside the resizable view because that one has the knobs. And it is also called add a point because the point defines what cursor detail is actually coming out of there. We'll also need we need to make sure that the page view is actually there. It could be that we are already being deallocated, and we can define an empty struct. And we also can get the results point. So remember, we are always in the coordinate system of the page view. And we want to convert the point to the resizable view. Why do we want to do that? Because now we're going to iterate over the knob type and the cursor mode in our mapping. And something you don't have to know, but it's very easy to find, is the resizable view has a function outer knob that will give us a knob if one is there. There could be various types of notation, so not all knobs always there for the knob type. And we just loop over everything, and if not, we just continue, because it could be that some knobs are just not there. Now, if we hit the knob, so if the knob frame contains the result point, now you see why I created result point and already converted it to the coordinates of the resizable view. Then we just fill the cursor struct. So cursor mode will be cursor mode. Remember, that's the cursor mode that's coming from this translation table. And the area of the cursor will be the knob frame. But we want again to convert the knob frame from the resizable view, because we don't know if there are any transforms on it. If we convert it, then it's definitely the right coordinate space. And then we can break, because it's unlikely that we hover over two knobs at the same time. And then we return the cursor. Awesome, this was a big one. Yes, Vish is also happy and removed error. Now, where do we call handle? Obviously, it has to be somewhere down there. So far, we just checked if we are in the resizable frame and return the default region. That is no longer good enough. Now say, give us the cursor, the struct, by handling the cursor inside the resizable view, add request location. Now we say if the cursor is an interesting cursor, not array, arrow, cursor mode, not the whole struct. Perfect. Then we will return a new UI pointer region with the rect of cursor area. Awesome. I'm checking and coding in me, but people are still there. Very good. All right, I think we have something that we can run. Let's see if that worked. So again, the cursor doesn't do anything. I select it, and we still have the full blob. So clearly, we forgot a little detail, and that is not always returning the default region, of course. And now we actually have what we want to achieve. I mean, not really, right? But you see that the cursor reacts on the knobs only. It's still not pretty, but it's definitely a big step forward. And our detection function seems to work great. So can you follow me so far? Can you give me a thumbs up or like a confused question mark or an awesome or anything? Awesome. Okay. So let's see what you want to do next. So next up is we actually want to create a cursor. And you have to know that there's a few ways how you can do cursors. I already used the prettiest one, obviously, which is a rounded rect. No, I'm joking. UI pointer shape, you can look at can take a pass, so a Bezier pass, or also a beam. Beam is just for text, so pass is really the one we want. Now, how do we get a pass? There's a few ways. For example, you could use some open source and import SVG. You could draw something in code, or you can use a hybrid approach and actually draw in an app that creates code. So a few of you probably have heard of Paint Code. I'm not affiliated with them. This is just who actually made it from Pixelcut. And it's a fairly simple editor, but I can draw a polygon. And what I actually want is two triangles that are flipped, so we have a resize. So I start with one triangle. The triangle has three sides. I give it a width and a height of 10. And I drag it all out there, so it's basically the centers in the middle. And then you see it there at the bottom, I can go to iOS, as you can say Swift, and actually can copy the source code somewhere in here. So I'm going to make some space. I'll just copy it in there. It will, of course, fail. Call it private single triangle. Bezier path for G size. We want to build it so it's scalable, and it will return a Bezier path. Now here's our code. I'm going to cheat a little bit because I didn't get the full center in my copy. So I used the prepared one, but you can manually adjust this. So it's the point that it centers is important because later on we want to also rotate it. And at the end, I added a scale function, so it actually takes the size. We know that we base it off of a 10 by 10 grid. You could also use 1 by 1, but then those coordinates get a little more messy. It doesn't matter so much in the end because we apply the translation anyhow. Awesome. So now we want to get down there where we actually define the pointer style. Remember, we had a rounded rect. This is no longer good enough. Now we say, first off, we want the path. The path is a single triangle Bezier path. Oh, we don't have a size yet, so I'm just making one up for now. Let's do 30 by 30. And instead of, oh yeah, still need a shape. So let shape be your pointer shape. Thankfully, the autocomplete is really nice. The path is the path, and then the shape is the shape. Don't need the block anymore. And if we run it, and if the demo gods are good to me, we switch to shape. Oh yeah, somebody likes Paint Code here. Hi, Tiago. Awesome. So let's see what happens when we do this. Look, we actually got a really nice shape. It's still not exactly what we want, but you see that we are getting closer one step at a time. What we really want is two triangles and not one. So we already have one triangle. So how about we make a new function? I'm being lazy, I'm just copying that one. And instead of a single triangle, let's call it double triangle. And also take the sides. And oops. Of course, the first polygon pass by calling single triangle with size. And we get the polygon 2 pass by calling it once more. And then we can also say polygon 2 pass append. Let's do the first one. So it's a little bit confusing. And the first one appends the second one and then returns the polygon path. Now this is still not really useful because we now just have two shapes that are on top of each other. We need to do a little bit of translation. Now how do we do this? We say apply. That would be like CG affine transforms because we're going to have a few of them. And we just say translation X. We need translation length. What could that be? Oh, thankfully we have size here. So let's just use size width. And we don't really need the Y coordinate, so we need to do this here as well, but with minus. Let's see if that actually worked. We go down again. We call the double instead of the single. And oh god, somebody really loves transforms. You people are weird. Let's see what we have here. Oh yeah, we have something. I mean, it's definitely getting closer, but we also need rotation. Now, if we go back here where we built this, we will need to rotate each of them. And rotating a path is actually fairly easy, but if you look at the UABC path functions, there is no default for rotation. Luckily, we can just cheat a little bit and copy a category. It's called an extension that rotates. Now rotating, what do we actually do here? We get the bounds, we get the center of the bounds, we start creating a transform. We translate the transform to be within the center, then we rotate by radians, and then we translate back and then we apply it. If you follow that rule, then you can like nicely translate something in the middle, clockwise or counterclockwise. So we go up again, and we call polygon rotate. Yeah, radians always like make my brain hurt. So we do want to work with radians wherever, but we can also cheat a little bit and just have a function that converts from degree. I always think a little easier in degree, so I'm just going to use this one. There shouldn't be any performance penalty. This is all very cheap. And you see I have to do it twice. So once I do it 90 degree, and otherwise we go counterclockwise. We start again. We pray. Oh, actually, see, I put the 2 on the wrong side. And if we did everything right, we actually already have something that looks pretty much like what we want here. It would even work, but on those other angles, not quite so much. But the good thing is we already have rotation, so why don't we degree to radians? Why don't we just rotate a little bit more? Second, preparing the next example for me. So when we look at the logic of our delegate stream, we did cheat a little bit here and just came up with a size. Now, obviously, what we really want in this delegate is having this cursor struct object that we figured out here. Now, when I first wrote this, I used some helper method. Of course, you can do it in the extension, so I had to define it up there and then copy it in. But that's not the nicest way. If you look at your pointer region, it has a second argument, which is identifier, and we can give it the cursor, and then in our region, we can get the cursor out again. Now, there is a little bit of detail. Identifier is any hashable, and our struct is not automatically any hashable. However, we can just make it any hashable. And now, if everything would be awesome, this would be all that you have to do, and it would infer hashability and equality automatically. However, it can't really do that from a rect. So we just define it ourselves. This changed in Swift a while back, so it's a hash function, and then we also need the equality function. I'm actually shortcutting this a little bit. I only check for mode, but for our case, this is good enough. Now, if Swift is nice to us, eventually this one will go away, and we can get the cursor detail in our second function out of the identifier. Of course, you have to cast it because this is just an identifier as any hashable, but we just cast it, and if it's wrong, then we return nil. Now that we have the cursor, we can actually use the size as cursor. Size. And see if this worked. No. Oh, of course, it's called hashable. Not any hashable. I have no app code. It's been a while since I tried app code. So let's see. It seems that size was correctly picked up. Everything is smaller, probably a little too small, but we can get back to it later. But we still don't have the rotation. So what we need again is we have our function that creates a Bezier path, and we create a new one that creates the rotated resize Bezier path by surprise using the double triangle. And calling rotate on it and then returning it. So this is the basic code. We get the double one, we pass on the size, we rotate with a magic radiance number, and then we return it. Now, how do we get it? This is a little bit of boring code, so I'm going to copy that in. We define radiant as float, and we use a switch over the cursor mode. And then remember, we have 4 cursor modes, but we have one that doesn't need to be rotated because it already looks good. So we just have north-south, northwest, southeast, northeast, southwest. We again use the degree helper because it's easier for my brain. And in anticipation of the future, we don't just equal it, we add it to the base radian value, which in this case is 0, but it might not stay at 0. So instead of where the double triangle path is, we go with the rotated path, and that one, of course, has a cursor mode. Cursor mode and the size. So let's see if we didn't forget anything. And surprise, it looks like everything worked. All 9 knobs are usable. I mean, obviously we didn't write that logic, but we wrote that they nicely transform. Now, this is already pretty good, but we still have a few minutes, and we want to do a few more tweaks to make it really awesome. We don't just want to stop at good. So let's see. So one thing you see that is not really perfect. I have to move my cursor very closely to the knob in order to transform. It would be nicer if we would give it a little bit of wiggle room. And we can do this by basically adding some edge insets. We go to our handle cursor, and instead of just checking on the frame, we make some UI edge insets, and then with an extended frame by using the knob frame and inset it by our knob edge insets. And then we check that extended frame for hit testing, and also pass on that extended frame for the cursor. That should make the whole make it a little bit nicer and easier for me to move around. Yes, you see that, and I can now have a larger radius where my cursor moves, but we also kind of messed up our cursor. It's now again way too large because remember, it uses the size. We extended the size because the cursor area is larger, but the actual knob is larger. So we need to add a little bit in our cursor detail structure. Now you see why I didn't use associated objects but a struct. We already have the cursor area, but now we also have the cursor size, and we just initialize it for our convenience with a 0. And then here, where we do the hit testing, we also give it a size. You could probably also like extract the edge insets into the mouse somewhere down there, but this gives us more flexibility in the future. So now I have area and size actually both the CT rect, so I'm lying a little bit here in the variable names. And then down there, the region is still fine. The region should be larger, but where we calculate the size, it should be size and not area. So the one without the edge insets. And then again, we check. I really like this changing a little bit and checking. So just make sure that this iteration is fast. Yes. Now we have the larger radius. It feels better, easier to hit with my clumsy fingers, and we still have the correct size. Well, it could probably be a little bit larger, but we can tweak this anytime. So, do you guys and girls think that we are already done, or should we do one more tweak? You can probably already see by my examples that we probably want to have one more tweak. Yes. So, of course, nothing is ever easy, especially not in PDF. And this is just in ink. Yeah, I can. Oops. I can show you. You can actually draw a little more here. It's fine. This not all works, but there's also stamps, and stamps can be rotated. So there's one additional knob that we haven't even thought about, and I'm not going to implement that one today. But you see the problem with the existing knobs? They rotate. Now, if it's not rotated, everything's great. But if it's rotated like this logic kind of breaks down. So you see, this is no longer correct. So what we want here is we actually want to capture the additional rotation and adjust, because we already do all kinds of rotations, so we can probably do a little more. Now, first of all, we need to extend our struct again. So we probably have a rotation value, and it's a CG float of 0. And then when we do the hit testing, we want to get the rotation. Cursor, rotation, and then we probably want to like do probably degrees or whatever. But where do I actually get the rotation? I can do resizable view, and I could look at all the properties that this PSPDFKit company exposes. But there's no rotation. There's a rotation knob. So that's really unfortunate. I'm gonna write them on support. And just imagine I did, because I'm not going to do it here. And they told me, oh yeah, we totally forgot that. But you can just use private API, as much as you can call it private if it's an SDK, and get it out yourself. So we know that we have an internal variable that's called content rotation. So what I did is I defined an extension to resizable view, implemented the property content rotation, and just use our key value coding, very crude, to get that thing named content rotation as a float out. We know, because we talked with them on support, that it's called like that. It will be public in a future release. For now, we just have to resort to this slightly ugly hack, but this is the price we're going to do to have awesome cursors. So now we have rotation. That's good. So we need to rotate. Of course, everything's a rotation here. So when we create our rotated resize Bezier path, now we give it a new parameter, call it rotation. And it gets the cursor rotation. Of course, we also need to define it in the function. So here it is, it's a CT float. And we just add that to our base and run it, and hopefully it builds. This looks like real code. Yeah, I'm trying. Let's see what's happening here. Oh, I think I got the rotation wrong, but almost right. So let's just add the minus here. Run this once more. Pray that I got it right this time. And let's see. Bam! We adopted to the additional rotation. This looks really like a pro thing now. Check it out. No matter how you twist it, it always has the very correct cursor. Now, of course, the rotation knob has no cursor yet. This is something for another day. But this is it. This is how we implemented cursors. Of course, I can give you a little outlook in what would be missing if we look at the finished example. There's a few details that I didn't have time. The cursor actually only in the coordinate space of the window. So if you zoom in, you should compensate for that. We were in a scroll view. We didn't zoom in. If you zoom in, this needs a little bit of a compensation. The cursor's alpha, our color cannot be adjusted. No. You really only get the shape. The shape automatically transforms. But we have Q&A later, so I'll go with all the Q&As. After all, there's one more trick that you should be aware of that Apple will never, ever tell you. But remember how we did all these checks for iOS 13.4? And of course, in the perfect world, this would be enough. But remember that through beta 1 to 4 or 5, there was no UI pointer interaction class. It was only added in the final GM version. So it's very wise, and you'll learn this eventually if you ship a larger product, to not only trust on the availability check, but also do a guard that actually checks for the class. There will be enough people out there that have beta versions on it, your app that has amazing pointer support, and your app will just crash because the class is not there. People will give you a 1-star rating. They do manage, even though they're on beta versions. People are very creative, or they then later update but don't try app again. This is something you can very easily avoid by just going a little bit extra mile. Think about beta versions and those special cases. It will also help you when you sift through your bug reports because there is less weirdness. Awesome. And with that, I'm going to end my presentation today and switch to questions. First of all, thanks for watching. And now we also have, please ask in the question answer module, because then it's easier and I can highlight all the questions. So First of all, yes, the recording of that will be available. Will probably still be called PSPDevKit for the foreseeable future. This question is about the cursor. I already mentioned that. So you only have limited choice. You can create paths. You can only have limited options there as well. So you cannot do fills. Apple doesn't allow you to any cursor or alpha, so you cannot just use an image. You have to deal with the restriction the system has. Cool. JB asked that. So this is a good question. I actually experimented with that, and if you go on the pspdevkit.com blog and search for pointer support, I wrote about that. In the ideal world, my idea was that I would take the cursor and as you rotate, also rotate the cursor. However, if you do that, the animation is not really great. It kind of goes back to being this round blob and then changes to the next form. I experimented with it. It was not a good experience. I think we will settle with like rotating at the entry point, then you can rotate, but the cursor stays the same. And when you like leave off, then readjust the cursor again. But these are details that you have to really try, and you have to try it on an actual device. There's also a fun detail that I didn't mention. If you can go in the debugger and then inject. There's a menu button that you can have your cursor in the simulator. But if you then hit a breakpoint, then your cursor is gone. You have to wiggle around a lot to hopefully find some space in macOS that changes the cursor because the default arrow is gone. But when you hit some area that will change the cursor, then it changes back to an arrow. So using an actual device is much, much better. Thank you, Matthias. Where will be your next live talk? I don't know. This is actually the second one. I did one for Swift Paris, which was very encouraging. That's why I'm here now. I guess we all are stuck with the Corona situation a little while longer. So this doesn't replace conferences, but it is the next best thing we have. And I hope I get invited to some more. This is definitely fun. Another question, that was really cool, thanks. Do you see other use cases not supported out of the box? Yes, actually, there is one large use case. And if you read the documentation on pointer events, you'll see that you have basic support with what we did here. But if you write gesture recognizers, there is no way to differentiate between the touch coming from a pointer and the touch coming from your finger, unless you implement a plist entry. I lost the name, but somebody can probably point it in the chat. Then the system switches to giving you actual new styles for indirect events. But then you actually have to rewrite a lot of code because a few of your custom gesture recognizers will probably rely on that. You could have zoom scroll events that have no touches at all. So if you have code that relies on this having touches, it will crash. So enabling this plist that will allow you to differentiate will actually be a lot of work. There is, of course, a private API way to get both, which I also like mentioning in my blog, which you shouldn't do, but which is very convenient when you debug and eventually. In our SDK, we will have to support both. Right now, we don't support the new pointer mode yet. There's a lot of code that we have to sift through. It's about 500,000 lines, but the goal is that we'll support both modes. Awesome. This was all of the questions. With that, I thank you all again for watching.